हेलो स्टूडेंट्स, कैसे हैं आप सभी लोग। उम्मीद करता हूं आप बिल्कुल ठीक होंगे एंड योर प्रिपरेशन इज गोइंग इन द राइट डायरेक्शन. So as the exam is approaching and the few days is left, so in order so that your preparation can excel in a more efficient way, Unacademy is coming with the most probable questions series. So in this series I will cover today's class. In this series I will cover the most expected 8 irrigation questions. So I am gonna to cover the most or expected or the top or the best 8 questions which can be coming in the GATE 2021 examination. So without any delay, let me start our class. That is the most or the top 8 irrigation questions. So top irrigation questions. So I welcome you all to the Unacademy, which is India's largest online live learning platform, with the help of which you can crack any examination. So let's crack it. So you can crack. So my dear students, you can crack GATE, you can crack ESE, you can crack any assistant engineer examination or any junior engineer examination with India's largest online live learning platform, that is Unacademy. You can take the plus subscription or you can take the iconic subscription. By taking the plus or iconic subscription, you will get an access to unlimited live and recorded courses from India's best educators. Moving forward, this is all about me. My name is Ehtisham Siddiqui. My referral code is ES001. I am alumni of India's topmost central university, that is JMI New Delhi. I am 4 times GATE qualified, 3.5 years of teaching experience, taught more than 10,000 students all over the India, guided students with the AIR rank 1. The subjects which I take: geotechnical engineering, water resource engineering, environmental analysis, structure analysis, surveying, construction planning and management. Moving forward, this is all about the Unacademy's learning app, which is a place of a very vast knowledge. So you can download the Unacademy learning app and you will get an access to unlimited live and recorded free courses in the form of special classes of the well-renowned educators. So just download it, and if you want to access my free classes, then just use my code ES001 in order to access my classes. Moving forward, this is all about what you will get. This is all about what you will get when you take the plus or iconic subscription. Basically, it is all about plus subscription: daily live classes, daily live tests and quizzes, structured courses, unlimited access to the recorded classes. But there is one more subscription which is introduces by Unacademy, that is called as iconic subscription. By the iconic subscription, you will take your GATE and ESE preparation to the next level with the help of personal coach. You will get a personal coach. Your study will be tracked. You will get the question answer practice of mains examinations, and you will also get all the benefits of the plus subscription. If you take the plus subscription, which is India's best platform, Unacademy's best subscription: daily live classes, structured courses, live tests and quizzes, unlimited access to the recorded classes. You will get learned in these live plus or iconic subscription. You will get learned from India's top educators like Marut Tiwari sir, Ankit Goyal sir, Sanchit Jain sir, and the god of civil engineering, Jaspal Singh sir. So these are the further more educators with the help of which you can take the educations. So this is all about the GATE and ESE course. We have launched 7 courses in GATE and ESE. Moving forward, this is all about plus and iconic, which I have already discussed. If we talk about the fees, 2 years fees is 44,000, 1.5 is 38,500, 12 30,200, 20 30,250 rupees. For 6 months subscription, the fees is 24,000. For 3 months, 13,750, and for 1 month, the fees is 5,500. But you don't have to pay this fees. Just use my code ES001. As soon as you use this code, you will get 10% discount and all the subscriptions. Okay, the fees which cost 44,000 will cost only 39,600 rupees if only use my code. This is all about the plus fees. If we talk about the iconic fees, to a 12 months iconic fees is 50,250 and 24 months is 74,000. Again, if you use my code ES001, you will get instant 10% discount. The fees which was 50,250 will cost only 45,225, and the fees which would cost 74,000 which cost only 66,600 rupees. So this is all about the new batches which are launched. This is the batch D for electrical engineering, If any of your friend is interested, he or she can be join the Unacademy Plus or Iconic subscription by using my code that is called as ES001. And by if you use my code, you will get 10% discount. This is the batch for the civil engineering for the GATE 2022. This is for the GATE 2023. All you will get the subscription and then able to access these courses by renowned faculties. Moving forward, today we are starting about the 8 important questions which can come in the irrigation for the GATE 2021. So the 8 important questions for the irrigation engineering for GATE 2021 we will discuss today. So the first question, let's start our class. So the first question, this is all about the first question. Let's try to solve this question. Let's try to solve this question. So what the question says, just read the question. If the depth of the moisture in the root zone at the field capacity per meter depth of the soil is 0.75 and then the field capacity in percentage. It's a very easy question, very basic question which can come in the 1 marks in the GATE examination 2021. What he is saying that the depth of the water in the root zone at field capacity, he is saying that the depth of water which is available in the root zone up to the point called as field capacity is 0.75 meter if the depth of root zone is 1 meter. Per meter depth बोल रखा है. He is saying about the per meter depth of the soil. So the depth of root zone is 1 meter. Depth of root zone, for every 1 meter, the water which is available in the root zone up to field capacity is 0.75 meter. What you have to calculate? You have to calculate the field capacity in percentage. If the unit weight of the soil, dry unit weight of soil is 16 kilonewton per meter cube. Dry unit weight of the soil is 16 kilonewton per meter cube. And you have to report the answer in the nearest integer value. You have to report the answer in nearest integer value. As you know, as we already know that the depth of water up to any point, either up to field capacity, either up to permanent wilting point, either up to the optimum moisture content, can be calculated by simple formula. If we calculate the water available in the root zone up to field capacity, then the formula will be equal to gamma D divided by gamma W multiplied by depth of root zone and multiplied as the we want to find the water up to the field capacity, then multiplied with the field capacity only. Multiplied with the field capacity only. You have given the gamma D is equal to 18 kilonewton per meter cube. Okay. You are given the depth of root zone is 1 meter. Depth of root zone is 1 meter. You are giving the depth of water up to the field capacity is 0.5 meter. It is equal to 0.5 meter. You are given the unit weight of the soil. It is not given. It means that you have to take 9.8 kilonewton per meter cube. All the values are given. Only you need to find the field capacity. So just move this all the things into the left side. So field capacity would comes out to be gamma W divided by the field capacity would comes out to be gamma W divided by gamma D multiply by gamma dW up to field capacity divided by D. When you substitute this value, 9.81 divided by 16 multiplied by 0.75 divided by D, that is 1 meter, the value field capacity comes out to be 0.4598, or it can be calculated in percentage as 45.98%. Since it is asked to report the answer in percentage, so the value in the integer form will be reported as 46%. You have to answer the value in the integral part, then the field capacity comes out to be 46%. So 46% is the right answer of this question. 46% is the right answer of this question. I hope you understand the answer of this question. So if you like the question, just give a thumbs up, subscribe our channel, and also you can share this video to all of your friends who want to prepare for the GATE examination and want to secure a minimum 50 to 60 marks, and they have not prepared from the last 1 years. So in these 7 to 8 days, you can prepare for your GATE examination with these most probable questions. Such type of questions can be asked in the examinations, because GATE examination is a very easy examination. Same concept questions, it's each year repeating. So that's why I am here to solve the most probable questions. So you can share this video to your friends who want to secure a minimum amount of marks in a minimum amount of time. Okay, so you can't get out 100 out of 100, but you can easily secure 50 to 60 marks with the help of these most probable questions. So you can share this with your friends. Moving forward to the next question. So this question is all about the irrigation water. What the question says, just read it. The question says the concentration of sodium, magnesium, and the calcium in the irrigation water are 25, 2, and 3 milliequivalent per meter respectively. The concentrations of sodium, magnesium, and calcium is given in the question. Okay. Moving forward, if he is saying that the electrical conductivity of the water is 300 micromaho per centimeter at 25 degrees Celsius, then the irrigation water is classified as. There are two things which are given. The first thing is all about the calcium, magnesium, sodium, and another thing is called as electrical conductivity. So first you classify the water based upon this sodium, magnesium, and calcium, we classify the water as sodium water, low sodium water, high sodium water, medium sodium water. So based upon the, if we talk about the classification based upon, and in order that whether the water is high sodium, low sodium, or very high sodium, we calculate the sodium adsorption ratio. We calculate SAR. This SAR is nothing but called as sodium adsorption. This SAR is nothing but called as sodium adsorption ratio. So based upon the sodium adsorption ratio, calculate the value of sodium adsorption ratio. As we know, sodium adsorption ratio is equal to the concentration of sodium divided by under root of calcium concentration plus magnesium concentration, and it would be divided by 2. Since the concentration of sodium is equal to 25 divided by under root of 2 plus 3 divided by 2 plus 3 divided by 2, the sodium adsorption ratio. So the sodium adsorption ratio, when calculate, the sodium adsorption ratio would comes out to be 25 divided by 2.5, and the sodium adsorption ratio comes out to be 15.811. As you know that this value lies between 10 to 18. This value lies between 10 to 18. What is this value? If the value of sodium adsorption ratio lies between 0 to 10, lies between 10 to 18, lies between 18 to 26, and it would be greater than 26. If the value of sodium adsorption ratio SAR lies between 0 to 10, then the nature of irrigation water is low sodium. It is called as low sodium water, and the symbol which is given as C1. Similarly, it is called as medium sodium water. Symbol is C2. Then the nature is called as high sodium water, and symbol is C3. And if the value of sodium adsorption ratio is greater than 26, then the nature is called as very high sodium water, and symbol is C4. It is called as very high sodium water, and symbol is C4. Since the value lies between 10 to 18, it means the sodium water is nothing but the medium sodium water. So the symbol will be used, that is called as C2. So the symbol would be used, that is called as C2. Now we'll move that this is the classification based on sodium or sodium adsorption ratio. Now we moved to the classification based on, now we moved on the classification based upon the electrical conductivity. Classification based upon the electrical conductivity, that is called as EC. On the basis of electrical conductivity, the classification as follows. The classification as follows. If the electrical conductivity, okay, you have to remember this table. If the electrical conductivity of the water is lies between 0 to 100, lies between, sorry, 0 to, if the electrical conductivity of the water lies between, if the electrical conductivity of the water lies between 0 to 250, 250 to 750, 7, and you have to multiply it by 3. So 752 by 150, 2250 and greater than 2250. If the electrical conductivity is less than 250, then the nature will be called as low electrical conductivity or low saline water. Then the water is called as low saline water, symbol is S1. If the electrical conductivity lies between 250 से 750 मतलब 250 to 750, then it is called as medium saline water S2. And if the electrical conductivity lies between 750 to 2250, it is called as high saline water, that is S4. And for very high saline water, the symbol which is used, that is called as S4. The symbol which is used, that is called as S4. Since the electrical conductivity, as in the question, the electrical conductivity is equal to 300, which lies between 250 to 750, it means the symbol would be equal to S2. The symbol would be equal to S2. If the symbol is S2, it means on the basis of sodium, the symbol is C2. On the basis of electrical conductivity, the symbol is S2. So the resulting symbol of the irrigation water would be equal to C2-S2. The resulting symbol would be equal to C2-S2. So the correct answer of this question would be D. The correct answer of this question would be D. I hope you understand that how we classify the irrigation water on the basis of sodium adsorption ratio, that on the basis of the quantity of sodium which is available in the water and on the basis of the electrical conductivity. Moving forward to the third question. Okay, this is the third question. Just read it, this question, and try to understand this question. It's an important question. You can able to solve this question very easily, but there are many students who can't solve it. So after solving this question, you will get an idea that you can, this type of questions can also come in the GATE examination in 1 mark. So moving forward to this question, so let's read this question. What this question trying to say? Read it. So the wetted area and the wetted parameter of a channel sections are this and this respectively. Wetted area is given as 6.25 meter square and the wetted parameter is 2.5 meter. If the average velocity of the water which is flowing is 1 meter per second, then the mean size of the sediment which is carried by the channel. Okay, he is asking about the mean size. Matlab he is asking about the D50. D50 is called as mean size. You need to find. So as we know that when we study the irrigation, then the mean size can only and only come when we calculate the silt factor, that is F. This mean size can only be obtained when we calculate the silt factor F. So but this silt factor can only and only comes into account when we are studying about the Lacy theory. When we studying about the Lacy theory, it means that in this question, in order to find the mean size, you need to find the silt factor, and in order to silt factor, you need to use the Lacy theory. You need to use the Lacy theory. You need to how will you use the Lacy theory? Just write the data which is given. So given, first you have to develop an idea what you have to do in this question, as he's trying to ask the mean size of the sediment, that he's trying to ask D50. As we know, the mean size is calculated by using the silt factor, and the silt factor can also be calculated only and only by the Lacy theory. So that's why I have moved to the Lacy theory. So given the wetted area is given as 6.25 meter square. The wetted parameter is given as 2.5 meter. if the average velocity of flow is 1 meter per second, then you need to find the Lacy theory. So based upon the Lacy theory, it is given as the mean velocity, and as we know, according to Lacy theory, mean velocity can be related to the silt factor as 5 by 2, sorry, as we know that the mean velocity, as we know that the hydraulic radius, sorry, as we know the hydraulic radius can be is equal to r is equal to 2 upon 5, r is equal to 2 upon 5 v square upon f. If you are able to remember this formula, r is equal to 5 by 2, r is equal to 5 by 2 multiplied by v square upon f. This is the hydraulic radius formula. So hydraulic radius can also be written as a upon p would be equal to 5 upon 2 v square upon f. 5 upon 2 v square upon f. Okay. So likewise, A is given as 6.25, weighted parameter is given as 2.5 is equal to 5 upon 2, and the velocity is given as 1 square. So on solving this, the silt factor would comes out to be this multiplied by 2.5. When we multiply this, it comes out to be 2.5, and this 2.5 will be cancelled this, then silt factor would be comes out to be 1. Silt factor would comes out to be 1. Now what you do? Silt factor is equal to 1, and as we know that the silt factor is equal to 1.76 under root of 1.76 under root of mean size in mm, under root of mean size in mm. F is given as 1, f is given as 1. So here the mean size in mm, is equal to 1 upon 1.75 ka whole square. When you solve this, the value will comes out to be 0.323 mm. So as the option C is correct, because the mean size is given as 0.323 mm. So this mean size would comes out to be 0.32 mm. The correct answer of this question would be C. I hope you understand. So these number of questions which we have discussed for the 1 marks. Now we discuss that what type of questions that can come in the 2 marks in the irrigation engineering. So this is the fourth question which can become in the 4 mark, which can become in the 2 marks. Just read this question, my dear students. Just read this question, my dear students. What he is trying to say, just try to understand what this question try to say. So the gross command area for the distributory is 15,000 hectare. Out of total gross command area, only 60% area is cultivable command area. Means that out of 15,000 area, only 60% area is that area on which irrigation can be done. That the land can be irrigated, but the intensity of the irrigation is 80% for the rabi season and 70% for kharif season. Out of 60% of cultural command area, out of 60% of gross command area, only 80% is used for irrigation in the rabi season and 70% is used for the irrigation in the kharif season. If the outlet discharge factor, what is the outlet discharge factor? It means the duty at the outlet point for the rabi and the kharif crops are this and this respectively, and if the time factor is this, then the design discharge for the distributory is. How you solve? Just write it. as it is given, the gross command area is equal to 15,000 hectare. Gross command area is 15,000 hectare. Out of these 15,000, if I talk about the cultural command area is only the 60% of CCA. Cultural command area is only 16% of CCA, that is equal to 9,000. That is equal to 9,000. Okay. Out of this 9,000, yes, what he is trying to say, out of these 9,000, only 80%, is irrigated in the Rabi season. If I talk about the area irrigated in Rabi season, then 80% of CCA, that is equal to 72. 80% of CCA, that is 0.8 into 9,000. 8 9 is 72. That is equal to 7,200 hectare. And the area which is irrigated in the Kharif season is equal to 70%. So 70% of 9,000, 7 9 is 63, that is equal to 6,300 hectare. Okay. If the duty of Rabi season, is equal to 1,000 hectare per cubic, and if the duty of Kharif season is equal to 1200 hectare per cubic, then he is trying to ask what is the design discharge capacity of the distributory. So if I talk about the design discharge of the Rabi season, so how you calculate, that would be equal to A divided by D. A divided by D, area which is irrigated in Rabi season, divided by area which is irrigated, duty of the Rabi season. But the thing is that this will only obtained when that whole of the irrigation period the canal is running, but the time factor is 0.8. It means that you have to divide with the time factor. You have to determine with the time factor. Similarly, you calculate the design discharge for Kharif season. So Kharif season, the design discharge will be equal to area irrigated in Kharif season divided by duty of the Kharif season multiplied by 1 upon time factor. Divided by 1 upon time factor. Okay, moving forward. Design discharge for the Rabi season would be equal to area is 7,200 divided by duty is 1,000 and divided by time factor is 0.8. So on solving this, the design discharge which is required for the Rabi season, would comes out to be 9 cubic, that is 9 meter cube per second. Okay. And similarly, the design discharge which is required for the Kharif season, that would be equal to 1,600 hectare divided by 1,200 hectare per cubic multiplied by 1 upon 0.8. On solving this, the design discharge for the Kharif season would comes out to be, just solve it and tell me the answer. Just solve it, my dear student. 1,600 divided by 1,200 and divided by 0.80, and it comes out to be 0.65. It comes out to be, it is coming out to be, my dear students, it is coming out to be, this design discharge for the Kharif season is coming out to be 6.5625 meter cube per second. It is coming out to be 6.5625 meter cube per second. Now that Kharif season and Rabi season are different seasons. They are not the same seasons. The crops are grown in the different times. So if we talk about the design discharge, then it comes out to be the maximum of design discharge which is required in the Rabi season or which is required in the Kharif season. This approach is used when the crops are of different seasons. So if they are of same season, then we will add up. But since they are of different season, then we will calculate by the maximum theory, and it comes out to be 9 meter cube per second. So the design discharge of the distributory or the canal will comes out to be 9 meter cube per second, since This question is numerical answer type question. The value comes out to be 9. So you have to substitute this value 9 here, because the answer is calculated in meter cube per second, and 1 meter cube per second is also called as 1 cubic. 1 meter cube per second is also called as 1 cubic. I hope you understand this concept, this question in a very nice way. If you can't understand, you can ask in the comment section. Okay, moving forward to the fourth question. This is the moving forward to the fifth question. This is the fifth question which can become in the GATE 2021 examination, or similar type of question can be asked in GATE 2021 examination. So just read this question and try to answer it. Just read. This is a very this type of question can be asked in the GATE 2021. So just read and try to understand this question. What this question try to say. For a particular month of a cropping season, there is a cropping season, and we are discussing about a particular month of a cropping season. The cropping season can be Rabi or it can be Kharif, and he tried to discuss about the particular month of a cropping season. The mean monthly temperature and the percentage sunshine hours of that area are this and this respectively. During this month, there is an effective rainfall of this. If the water application efficiency and the water conveyance efficiency are this and this, and the crop factor is this, then the gross irrigation requirement for this month is in centimeter. You need to find the gross irrigation requirement, and the gross irrigation requirement would be equal to gross irrigation requirement would be equal to net irrigation requirement divided by conveyance efficiency, and net irrigation requirement would be equal to field irrigation requirement divided by net application efficiency multiplied by conveyance efficiency, and field irrigation requirement is equal to consumptive irrigation requirement plus pre-sowing requirement plus leaching requirement divided by application efficiency multiplied by conveyance efficiency. Since the pre-sowing requirement is 0, leaching requirement is 0, it means I can say the gross irrigation requirement would be equal to consumptive irrigation requirement divided by net application efficiency multiplied by net conveyance efficiency, and consumptive irrigation requirement is equal to consumptive use minus net effective rainfall. Consumptive use divided by net effective rainfall. It is given that the application efficiency and conveyance efficiency is given, effective rainfall is given, and only you need to find the consumptive use. If you are able to find the consumptive use, you will get the answer. And the consumptive use, and the since percentage sunshine hours are given, on the basis of percentage sunshine hours, using Blandley-Cadel equation. Which equation? Using Blandley-Cadel equation. Using Blandley-Cadel equation. Using Blandley-Cadel equation, you can find the consumptive use as consumptive use is equal to 2.54 times of K multiplied by pH, percentage sunshine hours multiplied by TF divided by 100. What do you mean by TF? TF is the mean monthly temperature. If you have ever studied this formula, then TF is the mean monthly temperature in degree Fahrenheit. You have to write the temperature in degree Fahrenheit. What is pH? What is pH? pH is called as mean monthly percentage of sunshine hours. जो भी एक साल में बेटा आपके the amount of sun which is which give the sunshine in the whole year, what is the percentage in that month in which the crop is shown? So mean monthly percentage of sunshine hours. So K is called as crop factor. What is K? K is called as crop factor. What is K? K is called as crop factor. Based upon this data, CU can be calculated. CU is called as consumptive use, and its value will come out to be in centimeters. So if we want to try the value of TF, then the value of TF is equal to 9 by 5 temperature in degree Celsius. The temperature in degree Celsius is given as 18 degrees Celsius. It is given as 18 degrees Celsius plus 32. When you solve this, then the mean monthly temperature in degree Fahrenheit, mean monthly temperature, solve it, mean monthly temperature in degree Fahrenheit will comes out to be 64.4 degree Fahrenheit. 64.4 degree Fahrenheit. Mean monthly sunshine hours are given as, mean monthly percentage of sunshine hours are given as 7.2%. It is given as 7.2%. The crop factor is given as, 0.58. The crop factor is given as 0.58. Substituting this value in the above equation, on substituting this value in above equation, then the consumptive use is equal to 2.54. Crop factor is 0.58 multiplied by mean monthly per sunshine hours is 7.2% multiplied by TF is 64.4 divided by 100. On solving this, the consumptive use which is coming out to be, the consumptive use which is coming out to be, the value may comes out to be, just cross it, cross verify, the consumptive use in centimeter comes out to be 6.83 centimeter. So consumptive use is 6.85 centimeter. So if we calculate the consumptive irrigation requirements, so the consumptive irrigation requirement CIR will be equal to consumptive use 0.83 minus effective rainfall, that is given as 2.6, and the consumptive irrigation requirement would comes out to be 4.23 centimeter. If you solve it, the consumptive irrigation requirement is equal to 4.23 centimeters. So the gross irrigation requirement would be equal to consumptive irrigation requirement 4.23 divided by net application efficiency. Net application efficiency is 65% and conveyance efficiency is 80%. So this value comes out to be 65%, 0.65 multiplied by 0.80. So the gross irrigation requirement comes out to be 8.134 centimeter. It is comes out to be 8.134 centimeter. Since this is a numerical answer type question, you have to put the answer is as 8.13 is the right answer of this question. I hope you understand this question. The right answer of this question is 8.13 centimeter. Moving forward to the sixth question. This is the sixth question. Try to solve this question, my dear students. Okay, my dear student, just read this question, what this question is trying to say. He's saying the elementary profile of a dam having the base width 25 meter, if the dam is constructed using a material having a specific gravity this, and the values of uplift pressure coefficient C and the coefficient of friction mu are 0.5 and 0.35 respectively, then the allowable height of the dam. You have to calculate the allowable height. So this allowable height, H allowable, H allowable is calculated on the basis of minimum of the height which is calculated, based on the tension failure. There are two criteria on this basis the allowable height is calculated, and the second criteria on the basis of which the allowable height is calculated, one is called as tension failure and the another is called as sliding failure. Based upon the tension and sliding failure, the allowable height is calculated. Based upon the tension failure and based upon the sliding failure, the allowable height is the minimum of based upon the tension failure and based on the sliding failure. Okay, we will calculate in the below section that if we talk about the tension failure, if we talk about using tension failure, so as we know that the on the basis of tension failure, the allowable height h is equal to b under root gs minus c. So as base width is equal to 24, I think 24, 25. Base width is equal to 25. 25 multiplied by gs is given as 2.5 and c is given as 0.5. So gs is given as, my dear students, gs is given as 2.5 minus c is given as zero point 0.5. So on the basis of this, allowable height is coming out to be 35.5 meter. Allowable height is coming out to be 35.5 meter. Now we'll use the second criteria, that is called as using sliding failure criteria. If we talk about the sliding failure criteria, h is equal to mu into b times of gs minus c. On the basis of sliding failure criteria, h, height of the dam, is equal to mu into b. Mu is the coefficient of friction, so h is equal to mu is given as 0.35. Mu is given as 0.35. Width of the dam is 25. GC is 2.5 and C is 0.5. On solving this, H would comes out to be 17.5 meter. So on the basis of this, you have to take the minimum value. As you know, the allowable height is basically the minimum of these two. The allowable height will be equal to the minimum of these two. So the allowable height of the dam which can be allowed to construct based upon the above data is 17.5 meter. The correct answer of this question is 17.5 meter. So the correct answer of this question is 17.5 meter. Just write this answer in numerical answer type and it is nothing but 17.5 meter. The answer of this question is 17.5 meter. Hope you understand this question. Okay, moving towards the seventh question. This is the seventh question which is coming from a lined irrigation canal system. So just read this question. This such type of question can be come in 2 marks. Such type of question can come in 2 marks. Just read this question. Just read this question, my dear students. It's also a very easy question. So a lined irrigation canal with a triangular cross section having a depth 2.5 meter and having a side slope of 1.5 meter horizontal and 1 vertical respectively. The longitudinal slope of the canal is 1 in 1000 and the Manning's coefficient is this. Area of land in kilohectares that the canal can irrigate if the crop has 200 mm field irrigation requirement, matlab the depth of water which is required on the land is this, and the core period is 10 days. Is you need to find that what is the area of land that can be irrigated, okay, by the water which is coming through a line canal system. Okay, so the line canal system, so as the question says, the line canal system is this is a line canal system. As we know what we do, we make the corners of a line canal section as circular. Why? Because in order to avoid the silting, we make the corners of a line cross section as circular. So when we do is circular, then this has to be, so this is basically a triangular section. Triangular line section in which the depth of water, which is flowing, the depth of water which is flowing in this channel, is what? Is given as 2.5 meter. Okay, very good. The side slope is 1 vertical is to 1.5 horizontal. Suppose this is theta. So if we want to calculate the wetted area, then area would comes out to be y square theta plus cot theta. So if you calculate tan theta, so if this is theta, so this is also tan theta. This is 1 to tan theta is equal to 1 upon 1.5. So cot theta would comes out to be 1.5. Okay. So if we calculate the theta, so theta would comes out to be, so if we calculate the theta, then theta will comes out to be, it comes out to be 33.69 degree, but you have to put it into the radian. So what we do, multiplied by 3.14 and divided by 180. So it comes out to be 0.587. So just put it here. So area would comes out to be y is 2.5 whole square and theta is 0.587 and depth of flow is 1.5. On solving this, the wetted area would comes out to be 1.5 multiplied by 2.5 multiplied by 2.5. It comes out to be 13.05 meter square. Similarly, if we calculate the wetted parameter, then the equation for the lined triangular section, the value is 2y theta plus cot theta. On substituting the values, that y is 2.5 and multiplied by 2 0.587 plus 1.5, the value would comes out to be, solve it, the value 1.5 plus 0.587 multiplied by 5, the value comes out to be 10.435. Okay, you need to find the discharge. This is meter. So now Now area is calculated. So hydraulic radius will be equal to y upon 2. That is equal to, for the line triangular section, the r is equal to this. Now as this is line cross section, so we can use the Manning's equation. What you write? As it is a line section, as it is a lined, as it is a line channel. क्यों? क्योंकि कोई भी स्क्वायरिंग नहीं हो रही है. So what you can use? Q is equal to A by N, r to the power 2 by 3, s to the power 1 by 2. So Q is equal to, area is equal to 13.505 divided by N is equal to 0.016, r is equal to 1.25 to the whole power 2 by 3, and s is equal to 1 upon 1000 to the power 1 upon 2. On solving this, the discharge which comes out to be, on solving this, the discharge which comes out to be, you calculate it, and the discharge which coming out to be, the discharge which is coming out to be 29.93 meter cube per second. Discharge comes out to be this. So if I ask that if I ask if the discharge of the canal is this, as the canal is running for, because the core period is 10 days, so the canal has to be run for 10 days. So if I talk about the volume of water which is supplied, so the volume of water, if I talk about the volume of water which is supplied, okay, if we talk about the volume of water supplied, so the volume of supplied will be equal to, Q is equal to V upon T. So the volume of water is equal to Q multiplied by T. It is 29.93 multiplied by T. That is 10 days. 1 day is equal to 86400. So the answer would comes out to be in meter cube. Answer would comes out to be in meter cube. So the area which can be irrigated, so the area which can be irrigated, so the area which can be irrigated would be equal to, volume is equal to 29.93, volume is equal to 29.93 multiplied by 10 multiplied by 86400 meter cube, divided by how much depth of water which is required. That is given as, that depth of water required in the field is 0.2 meter, that is 200 mm. So as this value will comes out to be in meter square, the value in meter square comes out to be 2993 multiplied by 10 multiplied by 86400 divided by 0.2 in meter square. But you need to find the value in, hectares. So just divide this value, just divide this whole value 29.93 multiplied by 10 multiplied by 86400 divided by 0.2 divided by 10 to the power 4. So this value will comes out to be in hectare. Just solve this value. Just solve this value. 29.93 multiplied by 10 multiplied by 86400 divided by 0.2, and it would be divided by 10 to the power 4. So you need to find the value in kilo hectares. So divided by 1000 more. So the value would comes out to be 12.93 kilo hectares. Because in the question it is asked that you need to find the value in kilo hectares. So the answer which comes out to be 12.93. So the answer that comes out to be 12.93, because they are asking the value. If you are seeing that the area of land which can be irrigated in kilo hectares, so answer would be 12.93 kilo hectares. So the right answer of question number 7 is 12.93. I hope you understand this question. This question had came from the lined irrigation canal. So moving forward to the eighth or the last question. Moving forward to the eighth or the last question. So we are moving to the eighth or the last question. Just read this question, my dear students. Just read it. So what he's trying to ask, this question is a very good question, and such type of question can come in the GATE 2021 exam. In a farmland, in a farmland which is irrigated by a system of pumps from the wells, the area irrigated is 150 hectares. You need to irrigate an area of 150 hectares. Water is pumped from the well, is conveyed through a canal to the farms with a conveyance efficiency of 70%. Okay, the available moisture holding capacity of the soil is 25 centimeter per meter depth of the soil. Irrigation is started when the moisture extraction level is 50% of the available water which is stored. If the consumptive use of the crop is 10 mm per day, the depth of root zone is 1.4 meter, then the frequency of irrigation is, if the water application efficiency is 60%. So what he is saying, what he is trying to say, that you need to find the frequency of irrigation. So you need to find the frequency of irrigation. What he is given, just write the given data, because if you are able to write the given data, then the question become easy. Farmland, you need to irrigate an area of 150 hectares. You need to irrigate an area of 150 hectares. The water conveyance efficiency is given. He is saying the available moisture holding capacity is, water holding capacity is that the water which is available in the root zone is 25 centimeter per meter. So it means if the root zone is of 1 meter, then the water available per meter of the root zone is 25 centimeter. Okay, he is saying that the irrigation is done when the moisture extraction is 50% of available moisture. So and the consumptive use cu is equal to, मतलब एक दिन में 10 mm पानी खर्च हो रहा है, 10 mm water is lost due to the consumptive requirements. Now he is saying the depth of root zone is 1.4 meter. So if I ask about the depth of water available, if I ask about the depth of water available, if I ask about the depth of water available in root zone, if the depth of water available in root zone, for every 1 meter, the water which is available in root zone is 25 centimeter. So in 1.4 meter, the water which is available is 1.4 into 25 centimeter. When you multiply this, my dear students, then 1.4, then 1.4 multiplied by 25, the depth of water which is available in the root zone comes out to be 35 centimeter. What he's saying, that the irrigation is done when this depth of water available reaches to the 50%. So if I talk about the maximum allowable deficit, if I talk about the maximum allowable deficit, how much water is allowed to fall before the irrigation, that is 50% of, that is 50% of 35, that would comes out to be 17.5 centimeter. That comes out to be 17.5 centimeter. Now the frequency of irrigation is nothing but maximum allowable deficit, that is equal to maximum allowable deficit divided by consumptive use. Maximum allowable deficit is 17.5 centimeter and consumptive use is equal to 10. One second, let me check it. Is it the right data available or not? So this is given as 10 mm per day. Okay. Okay. So maximum, the data is given right. Maximum allowable deficit is 17 and consumptive use is 10 mm per day. If you convert it, that would be equal to 175. It would comes out to be 175. It would comes out to be 175 mm divided by 10 mm per day. So mm will be cancelled out by mm. then the frequency of irrigation, would comes out to be 17.5 days. As the frequency of irrigation is always rounded off to the lowest integer value, so as the frequency of irrigation, you have already discussed, but you have to remember that the frequency of irrigation, is rounded off to lowest integer value, lowest lowest integer value. So the frequency of irrigation would be equal to 17 days. So the frequency of irrigation would be equal to 17 days. So right answer of this question would be equal to 17 days. I hope you understand. So we have discussed the 8 questions which can come in the GATE examination. So just revise these concepts, because in GATE examination such type of questions are usually asked. I request everyone that just subscribe our channel and share this video to all of your friends as maximum as you can, because you can crack GATE and ESE only and only when you follow ourselves. So if you like the video, comment. If you give any suggestion, comment on the YouTube. Just like this video, subscribe our channel and share this video to all your students who are preparing for GATE 2021. Join the Telegram channel for more updates or for plus and iconic subscription queries. If you want to take the plus or iconic subscription, just use my code ES001. And if you want to know the more queries, if you have some doubts, if you have need to some clarification regarding the GATE and ESE subscription or any examination subscription of ESE, GATE or any examination subscription that is plus or iconic subscription, you can just visit the Telegram channel named with Civil by Siddiqui sir and just message to Siddiqui sir. Whenever Siddiqui sir will be free, he will surely help you regarding your queries. Thank you so much. Take care, keep rising, keep revising, and don't lose your energy, don't lose your hope, because you have already prepared for the whole 1 year. Now this is a very crucial time. Do not lose your hope. Just be energetic and just push yourself, because only 10 days are left. Just push yourself daily. Just give the task daily to you so that you will feel motivated. Just give the task, just solve those questions in those tasks, and I will assure that you will able to crack a very good rank. Thank you so much. Bye bye. Take care. Let's meet in the next class very soon.